All right, good morning, everybody. Thank you for taking the time to consider James Madison University as one of your choices for higher education. I think that you're going to like it. I can say that to you honestly because I know that I love my job here. I love teaching at James Madison. And I love living in the Shenandoah Valley. Whether I'm riding my dirt bike on the Rocky Run trails that are on Route 33 just west of the city, or whether I'm riding my race bike on the Summit Point racetrack just north of here in West Virginia, or on the Virginia International Raceway that's down south by Danville. I've had a great time in this natural paradise. It's a wonderful place for hiking and camping. I'm also into mountain biking. And if you just go over the ridge, you can get into one of the most diverse ecosystems this side of Alaska. It's Cranberry Glades. It's a wonderful place to spend 4 years of your life. And it's great to teach here. The opportunities that I've been given by the administration are phenomenal. And they've allowed me to incorporate the things that I love. There's my motorcycles, my mountain bike up there. They've allowed me to bring the things that I really love, not only into the classroom, but to develop a research program that's totally built around the things that I would do, given the option, if I could do whatever I wanted. Now, the first project that I engaged with when I got here, the first thing I wanted to do was make an alternative fuel motorcycle. I thought that would be wonderful. But the ball really got rolling when one of the ISAT students, Randall Morrison, top left, he convinced his Uncle Chucky to donate that motorcycle you see there, a 78 Yamaha that had been behind the shed, behind the barn for years, all weeds growing up through it. He gave us that, and then a teacher from the local Votech school in the diesel program, he gave us that diesel engine that you see in the middle. And then I sent the students out to scour the area, to go to the salvage yards, the junk yards, to see what they could come up with. And they found that. Beautiful piece of machinery. That's a 1973 Volkswagen Super Beetle. And I said, you know what? I'm going to step up to the plate too. I'm going to take $50 out of my pocket and I'm going to buy that for you guys. We brought everything back to the shop, and there's the team of students right there, and they quickly started taking everything apart, disassembling it. The project took on a life of its own. These guys dominated. They showed me very, very quickly that they are outstanding at taking things apart. Took them a little bit longer to put it back together because they had to learn a lot of skills. They had to learn a lot of things that they weren't exposed to until they got here. And I am so happy to have Prins joining the team now because he is doing an excellent job of bringing these things to fruition.
Thanks, Chris. Howdy. As you might imagine, completing a project like the biotrike takes a lot of time and dedication for the students, but it also requires skills that the students don't necessarily carry with them into the project. It takes time to develop those skills. You need to learn the skills, then you need to practice the skills, and then you need to actually apply them to the project that you're working on. All of this together, this process, gives the students a lot of hands-on experience with working with equipment that they're not familiar with before. At the Alt Fuels Lab, most of the work gets done in the evenings during supervised shop hours. Students end up using tools like the lathe, the mill, the drill press, cutting tools like the bandsaw and the cutting torch, other tools like welders and grinders. So if you were to walk in the middle of the week and see them working, you'd see students working on projects, building things, working with shop tools, sparks flying everywhere sometimes, and it looked like people are generally having a pretty good time. But the point of this is not really to make fabricators out of the students, is not to even build cool demonstration vehicles like the biotrike. What the point is that we believe that hands-on experiences like that enhance the students' ability to understand what they're learning in their books. Okay, and this also improves their ability to communicate to a broader range of technical people. This sort of thing is very applicable for students out there that might be interested in getting into design or manufacturing, whether that might end up being on the engineering end, the management end, or in operations. But overall, it's also, from the big picture view, it's important to develop project management and teamwork skills that you really can't learn in a conventional classroom. So with that, I'll turn it back over to Chris to talk about some of those projects.
We currently have 3 student teams that are operating in the Alternative Fuel Vehicle Lab. And these guys decided to get together, and they started the JMU chapter of the Society of Automotive Engineers. We've got 1 team that are working on the design and the construction of an off-road mini Baja race car. And the thing that's really challenging about that is it has to be amphibious. It's got to be able to float and turn and navigate in the water. We got a 2nd team that's looking at electric vehicles. They're looking at novel methods of harvesting energy and storing it in these electric batteries, in addition to connecting them to solar panels and even wind energy. And then our 3rd team is working on the design and construction of a single-occupant, ultra-high fuel efficiency vehicle. Now, the Department of Energy, in their schemes, their roadmap for the future, fuel efficiency is really a key part of that. Y'all in the audience, especially the students, are going to have to prepare for a world that's going to be dealing with ever-increasing prices of fuel and the inevitable loss of oil. You're probably going to witness that in your lifetime. We've got to get these vehicles fuel efficient as soon as we possibly can to give more time for the scientists to try and figure out an alternative to oil once it's gone. Now, of course, at the AFV, at the Alt Fuel Lab, we are interested in these alternative fuel options that we're going to need to replace oil. And we've got student projects where students, they designed and built a small-scale biodiesel refinery. And then they used the waste oil from the JMU dining halls, and they converted it into biodiesel, and we use it in the biotrike. If you want to go see it, it's right up at the top of the stairs in front of the ISAT building. We've got students that are working with biotechnology and looking at the biotech applications of genetically modifying yeast so that they can have the genes from a fungus in the yeast so they can degrade cellulose, cellulosic biomass, plant matter, and convert it into a usable fuel. Now, for those of you that are interested in the alt fuel, you probably know that that is on the very cutting edge of the Department of Energy's research agenda. They really want to get cellulosic ethanol. So we're integrating all of these projects together to try and find a comprehensive solution that is going to be environmentally sound, because we're much more aware of the environmental impacts of these things nowadays. We want to make sure that this can fit in with the infrastructure that we have and help make that transition occur. And you always have to consider whether or not these things are going to be economically viable. So you really have to look at a diverse range of things. And one of the projects that we are really excited about is the algae, the aquatic species program. We're looking at single-cell microalgae because these are some of the fastest growing plants on the planet. They pull in the CO2 from the atmosphere. They use the sun's energy to rearrange those molecules. And they store that sun's energy in the form of lipids, fats, or carbohydrates, the sugars. And if you can unlock that potential, then you've got an opportunity for a renewable energy source that doesn't compete with our land and our food production.